Hi, I'm Khrystyna Klimash, and you're on a podcast, Building Digital Product, where we speak about the technologies that can boost your business here and now. And today's guest is Peter Cotton. He is a seasoned data scientist and entrepreneur in the quantitative finance industry. Peter is co-founder and chief scientific officer at Crunch Labs, where he leads the development of real-time data feeds and predictive tools. For years, he has been chief and senior data scientist at investment firms, where he managed multi-billion-dollar portfolios. Additionally, Peter is the author of the book titled Microprediction. Hello, Peter. Glad to see you here.
Hi, Khrystyna. Thanks for having me on.
You're a data scientist with an impressive background. Based on your experience, what type of businesses and which industries need data, great data science most, and why?
That's a good question. I mean, ultimately, they all do. I would say that the financial sector has obviously been faster to the game than most. It's been 40 years of data science and finance, but certainly not the only areas. I think plenty of other areas, manufacturing and so forth, used operations research for years. I'd say it's just being more widely adopted now than it ever has been. More things are being measured and instrumented, and so the use of quantitative tools is perhaps more relevant than it used to be.
When discovering the essentials of your book Microprediction, I was truly impressed by your proposition on how a web-scale network of autonomous micromanagers can challenge AI and even offer low cost of business optimization. Could you please explain the concept of microprediction and how it differs from traditional AI approaches?
Sure. So I guess first to just define the term microprediction as I use it, it's just my shorthand for referring to a sequence of tasks that usually a sequence of predictive tasks or analytic tasks that needs to be performed over and over again, thousands or millions of times. And I think that domain of application is important because if you have a sufficiently large number of data points flowing, then you can determine whether a model is good or bad, whether data is useful or not, whether somebody is contributing, is adding value or not. And so you don't face the small sample problems as much. So the book is about rethinking how we bring algorithms to problems in that particular microprediction domain. And it tries to confront head-on the core problem, which is that the world is full of algorithms and full of data, and it's impossible for any data scientist, however seasoned or knowledgeable, to possibly get a grasp on everything that could be brought to bear on a given problem. It feels a bit like, a librarian, the Dewey Decimal System trying to sort of harvest all the world's knowledge and be in a position to answer any question. Simply not plausible. So in the same way that, document search was solved by a network. The proposition in the book is that search in the space of data and models will also be solved by a network. And that network is going to comprise or be inhabited by what I call micromanagers, which are algorithms which have some navigational ability and some economic common sense. So that's the kind of general proposition. It's this notion that we can take business problems, turn them into commodity repeated tasks, and then allow anyone to attack those tasks or some subset of those tasks by launching algorithms.
How this might be applicable and useful for small businesses and startups?
Well, I think it's particularly useful because it's unbelievably cheap. So if you're a small business and you wanted to predict how many lattes you're going to sell in the afternoon, or when shipments would arrive, or whatever. And as long as it's a regular task, then in theory you could just post that number, to a sort of general purpose prediction API that I call an oracle, and that could be an interface. And behind that interface, anyone who thinks they can predict your number, or any algorithm that thinks they can predict your number, would be able to do so. And it's incredibly cheap ultimately because those algorithms are not just necessarily designed to predict your number. They could also be doing 1,000 other tasks. So the sort of amortized costs can head towards zero pretty quickly.
Based on your experience with Microprediction and CrunchLab, what most important advice would you give to someone looking to create a data-driven digital product? Because our listeners actually would like to create different digital products, and for them it will be really useful to hear.
Yeah, so we're in a somewhat privileged position at Crunch. We have 5,000 data scientists across the world who are all very good. Yesterday I was trying to compete with them, for example, on the causality discovery challenge, and I'm struggling to get on the top page of the leaderboard. So there's a lot of talent out there. I think the question is, how do you take advantage of it? And I think the first step is to realize that you don't know everything and your model isn't perfect. And an obvious corollary of that is that if you're building some prediction model, it's going to have errors. And those errors are going to generate a time sequence of, let's call them model residuals. Well, there might be signal in them, and you might not see it, but somebody else could. And so I think, starting from the sort of the back end of it, I'd say, look at your model residuals, but don't assume you're the only one who can find signal in them. And so if there's a mechanism whereby you can get them in front of other people, that's probably an easy way to start improving your own output.
You have worked on privacy-preserving machine learning. How can digital product creators ensure they are using data ethically while still leveraging its power?
Oh, well, I mean, the first, it's a massive topic, obviously. And maybe I'll just make in terms of the ethics, but I'll make a small comment maybe just in case people aren't already aware of this. There is a body of knowledge that's called, generally referred to as secure multi-party computation that I would encourage any sort of mathematically curious person to poke into, because it is essentially the study of how do I compute a function of dataset A and dataset B without the owner of dataset A revealing its data to B or conversely. And so there's a whole theory built up around how you can cleverly kind of dissect your data safely into kind of randomized, shared secrets, as it were, and then through a series of protocols exchanging numbers back and forth, somehow magically arrive at the answer to the thing you want to compute without leaking information. So that's a fascinating area. Another one that's slowly coming of age, of course, is homomorphic encryption. One that we use at Crunch a lot is differential privacy. So if we're asking people to look at a data set and we don't want anyone to be able to discern things about an individual record in that data set, then we'll look into that theory in order to figure out exactly how much noise to add. So it's quite a few different areas, actually. There's no silver bullet.
How do you see the relationship between human expertise and machine learning evolving in the coming years, particularly in decision-making roles in businesses? I know it's challenging and hard to predict the future, but do you have any thoughts or ideas based on this?
So I'm going to go back to this dichotomy, and I try not to make prognostications on the side which refers to kind of infrequent decisions. And, if you're deciding what to study in college or something, I really have no advice for you, other than make sure it includes math. But and when it comes to decisions that are made, thousands of times a day, should I hit a lift and offer, or is my machine just about to break, or things like this. That seems to me inevitable that there's going to be a little bit of an inversion of control eventually. So at the moment, humans still have this sort of an entrenched role as hand holders of models, and we go into the problem and then we kind of write some code and bring the analytics to the problem and deploy it and so forth. And we're kind of the boss, right? But in the future, I don't see it necessarily being like that, because it's relatively easier, I would say, to design systems which can be mechanically improved as more things come along that are better. And at that point, it's really kind of some algorithm, might be a market mechanism, might be some selection process, whatever, that's really governing the process. And the human comes in if they're useful, right? But eventually it might just be the human kind of prompting and saying, hey, we're using this algorithm, maybe we should use this one instead. And that's the only hint the LLM needs to go off and like write a new model, test it, deploy it, and so forth. So I can certainly see a future where humans are called upon for their kind of sporadic contributions of generalized intelligence, but that kind of contribution might be kind of on the scale of 10 seconds at a time and not 10 hours at a time. So it'll be interesting. Always hard to predict these things, but I think that sort of decentralized AI is going to have a lot to do with it.
Do you think it would be challenging for machine learning to fully or partly replace humans in the decision-making process?
I mean, they've been replacing them for years. A lot of the trades that occur, of course, in finance don't have any human intervention, and many have humans only as a last look, and that's true of many industrial processes, of course. Not to mention navigation and the obvious things that are going on in the automotive industry. Most things get automated these days, so I would say we're already replaced in large part. And the question is, where will we ultimately still be useful for our decision making? I think probably for kind of the sort of medium longer term decisions. But even then, it's an interesting one when you start to look at how far we've come in the last 2 years with generalized reasoning ability with LLMs. They may not do all the things we do, that's for sure, but they can do some things that certainly meet some definition of reasoning and generalization and analogizing and abstraction and so forth. And they can do some of that, and they can do it broadly and at scale. And so I would say any prognostication on how decisions are going to be made 5 years out even is difficult now. Things seem to be speeding up.
Yes, I feel like everything is accelerating and the world is changing dramatically. That makes it tough to predict what things will look like in just 5 years. But 5 years from now, development will likely be even faster than it is today, because everything is advancing at such an incredible pace. It's fascinating to think about.
Yeah. I mean, no, absolutely. I mean, when I wrote my book, the Microprediction book, I thought, well, I really think this is sort of where things might go, but I don't know if it's 5 years or 50. And then LLMs came along, and all of a sudden it's like, oh, okay, algorithms can navigate, algorithms can think, algorithms can fight their way through APIs. They can do all these things now. So, whoa, maybe this is 5 months, not 5 years, and then, on top of that, with O1 preview coming out recently, I mean, looking at sort of what you can do when LLMs have a bit more time to sort of plan themselves and think or reread their answers, and all sorts of, all these sort of patterns. OpenAI's obviously chosen some of their favorite ones and put them in a product. Who knows where that will go? I mean, it's, you wire up these things and you train them over however long it is, weeks or months. Our wetware has taken 500 million years to train. So those who I think are dissatisfied with the level of intelligence thus far on the artificial side, might be in for a surprise in the future.
I agree. Thank you for answering all the questions. Right now, we will move to the next section. I will give you 2 options, and you need just to pick the one. Are you ready?
All right. Yep.
Physics or mathematics?
Oh! That's tough. That's tough. I studied physics undergrad. I took the same subjects in both physics and math departments. I preferred the teaching in the math department. It was more geometrical and interesting. So I'm going to go with math.
Okay, scaling a business or optimizing it?
Scaling.
R or Python?
Python.
Australia or the US?
Goodness. Which sport? I'm happy in my life in the US, but my heart will always be in Australia. Yeah.
To invest or being invested?
Be invested.
Thank you for coming to our show today. It was really nice to meet you and talking with you.
Thanks, Khrystyna. Thanks for having me on.
Click like and subscribe button to not skip the following episodes. Bye!